welcome to lecture number 15. So, we have been discussing about the classical orbital elements. So, we will continue with that, and also what we have done that from the burnout data means already I have stated that R 0 and V 0 is given. So, find A, this is given, find A, E, I, small omega, capital omega and theta. Okay. And then there will be the inverse problem of this. So, inverse problem of this will be given A, E, I, capital omega, small omega and theta. So, from there find x, y, z, x dot, y dot and z dot. So, these are the two problems. So, as I told you mentioned you earlier that we will be doing by the scalar method also finding these elements. So, already we have done all these things, and also while working out I have done it by the scalar method. So, few things this also I have done by the scalar method. So, omega and theta already we have done by scalar method also. So, only thing remains about the omega. So, I will quickly work out this and then we will go to the inverse problem. So, we have written R 0 equal to x 0 E 1 cap, y 0 E 2 cap and z 0 E 3 cap, and v 0 equal to x 0 dot E 1 cap E 3 cap. And from there then I have to derive this H we have already derived, which is R 0 cross V 0, and that we have written as this expression. See, it's difficult to remember, but if you know the basic principle you can always work it out. Okay. Any time we can work out. So, for saving time I have to refer back. Okay. I am not finding those materials. Okay. Anyway, for this we can write as y 0 z 0 dot minus y 0 dot z 0 E 1 cap plus x 0 dot. Just look back into the previous lectures I have done here. This part I am writing this part there. Okay. So, we utilize this and see rewriting the whole thing there for ready reference. E 2 cap and then x 0 times y 0 dot minus y 0 times x 0 dot E 3 cap. We will write in a proper sequence. This is z 0 times x 0 dot minus z 0 dot times x 0. The same sequence we are following. Okay. So, whatever I have written here, so I will verify with the our earlier derivation. It will take a few minutes. Y 0 z 0 dot and y dot 0 z 0, then x dot 0 z, this is okay, x 0 x 0. So, x 0 here the same thing has got repeated. See the mistake we have done here. Okay. E2 is x 0 z 0 dot, this is fine, and here this is E3 is x 0 y 0 dot, this is y 0 dot. So, we have to correct it, x dot equal to x dot 0 y 0. So, this is a big error. And this will be, this is a big error that has crept in. That is why I wanted to verify. By writing copying from one place to another place, we this kind of error creeps in. Okay, anywhere. H 2 is x 0. So, here this is okay. We have done mistake in S 3. Okay, so, this is fine. Okay. S 3 is appearing anywhere. Here S 3 is appearing. So, this place we have to do the correction. This is S 3 is x 0 y 0 dot and x 0 dot times y 0. So, this is the correction required. So, I will note it down so that I can correct in later on. Lecture 13, this is okay. So, this correction is required here. So, already I have told you that this type of error creep in while writing, where the attention gets diverted while thinking of the subject. So, I hope we do not have any other place this mistake. So, this all okay. These are all okay. Just we have done the correction here, the correction is there. This is y 0 and this is y 0. X dot y 0. Okay, so we have been here in this place. So this is fine. This part is okay. Y 0 z 0 y dot z 0 z 0 x. This is okay. Okay, so now we I told you that we will do the same thing through the scalar method. So, scalar method whatever we have done earlier, it is almost the same, there is nothing new in that, but still some possibilities are there to explore it further, and let us go through that quickly. So, that we in this lecture we are able to finish it. So, H we are writing as H times E h cap, and already the equation for this we have written. Okay. Now, we need some diagram to work it out. The projection of this will show again by a dotted line. So, this is the projection of the orbit. Perigee line we are showing somewhere here. This is P, and so this angle, this is small omega, and this angle we will write there as m, and this angle we will show it as cap 90 degree. So, showing like this means it is a 90-degree angle, and then we have the satellite here in this place. So, this angle we are showing from this place to this place as theta. So, angle between these two, then this becomes omega plus theta minus 90 degree. Now, projection of this m onto the x y plane, this will write as m prime, okay. And then we can join it by a line like this, and this line we will extend it on this side, and we will write here m double prime. This is O, okay. Because this angle here, this is 90 degree. So, therefore, this wedge shaped part we have drawn here, this is O m prime m, this angle also this is I, and normal to the orbit, this angle is also I. So, here I am not showing, but because of this figure will get much more complex, it will look bad. This angle is from this place to this place, this is capital omega, this we have written as n, this as n prime. Okay. So, if we take the x y plane, this is the x direction, y direction, okay. This is the x and y direction. Okay, nodal line, it is appearing between x and y. So, the nodal line is appearing like this. So, this is your n prime and here it is n and this point is O. So, here O m prime, it is a perpendicular to the line O m is perpendicular to O n, and also O m prime, this will be perpendicular to O n. So, here we will have O m prime and on this side we will have here m double prime. Okay, so, this is the construct. Now, this angle we have written as capital omega. So, naturally this angle, then this becomes capital omega and this angle also gets to capital omega, this angle will be capital omega and rest accordingly this angle will be capital omega minus 90 degree, 90 minus capital omega. Okay. Now, we can work out this part. So, E n cap, which is the unit vector along this direction, we have written as cos capital omega E 1 cap plus sin capital omega E 2 cap. This already we have done. Also, we have E O m prime, this unit vector along the E O m prime in this direction, this will be equal to minus E cap O m double prime. And how we can write the E O m prime vector, unit vector, this will be E 2 cap is along this direction. So, cos capital omega E 2 cap, and from here this place, this is plus cos 90 plus capital omega E 1 cap. So, this becomes minus sin capital omega E 1 cap plus cos capital omega E 2 cap. So, therefore, E cap this is O m prime, here it is E cap O m double prime, this will be equal to minus of this as we have written here from this place. So, this will be sin capital omega E 1 cap minus cos capital omega E 2 cap. So, why we are trying to do like this? There is a reason behind this, which will be shortly visible to you. This angle is I, therefore, this angle is 90 minus I. Okay, this is each vector here. So, each vector we can break along this direction, also we can break along this direction. It can be broken along this direction and this direction, or either we can take unit vector component along this direction, unit vector from this component along this direction to get unit vector along the h direction. So, this is the process of working. So, already we have written U O m this. So, we have E h. What I was telling that this can be broken along this direction, or either we can calculate unit vector along this direction, which is E h cap. So, E h cap unit vector will be E 3 cap cos I plus E cap O double m prime cos 90 minus I. So, E 3 cos I and then plus E O m double prime sin I. Now, insert the value for the E O m double prime. So, E O m double prime is sin I, sin capital omega E 1 cap sin capital omega E 1 cap minus cos capital omega E 2 cap E 2 cap and plus cos I times E 3 cap. So, this is the situation here, sin capital omega E 1 cap minus cos capital omega E 2 cap plus cos I times E 3 cap. And sin I and here this is multiplied by cos I we have written here, one part we are forgetting. So, I will have to rewrite it. See, we have this part we have written first. So, sin capital omega E 1 this part, then this multiplied by sin I, this is the missing part, and then cos I times E 3 cap. So, we expand it, sin I times sin capital omega E 1 cap minus sin I times cos capital omega E 2 cap and cos I times E 3 cap. So, this is E h cap, the unit vector along the h direction. So, once we have got this, now h vector already we know, this h vector E h will also be equal to h by h. So, h we have already written, this is h 1 times E 1 cap, h 2 times E 2 cap plus h 3 times E 3 cap divided by h. So, this must be equal to this quantity here, and therefore, h 1 by h, this we can write as sin I times sin capital omega h 2 by h equal to minus sin I times cos capital omega and h 3 divided by h equal to cos I. So, first we take the cos I equal to h 3 divided by h, and h 3 if we go back, h 3 is the quantity, this one x 0 y 0 y 0 x 0 dot x y So, already I have told you there is no ambiguity in getting I, because the from here the I varies between 0 and 180 degree. So, exactly you are going to get the right value of the I using this expression. So, there is no problem in this. Okay, and this is the same thing we have got from the using the earlier method, only thing there we wrote it wrongly while writing it. So, that correction I have done right now, you have seen it, but also I will introduce it in the video, that I will have to edit the video. Okay. Okay, so, then the other two we have here h 1 and h 2. Using this, sin is common to, sin I is common to both of them. So, using this we will be able to determine sin capital omega, this the capital omega angle. Okay. So, this is the same thing what we have done here. So, H 1 equal to H times sin I times sin capital omega, sin I times sin capital omega, and H 2 equal to minus H times sin I times cos capital omega. This is what is here. Okay. Now, look here in this part. This part is always positive because I lies between we can see here 0 degree means your orbit is just in the lying like this along this direction, and 180 means it is just going in the opposite direction. So, we can put here also the equality sign, it is not a problem. So, it varies between 0, that means in one case the satellite is going here in this direction, another case satellite is coming here in this direction. So, here equality sign is not a problem. So, it varies between 0 and 180 degree. For I equal to 100, the problem will be that sin 0 equal to 0 and sin 180 equal to also 0. This is the problem. So, which one then it is referring to, that you have to decide, and that is why I told you that if we just keep this part. So, this ambiguity will not be producing. Okay, so, we do not have to produce the ambiguity. So, in that case, while I equal to 0, so we are getting this 0 value, and when I is less than 180 degree. So, still it will be positive, but it will have certain value. That means, our figure it goes like this. So, I was discussing something, I have strayed somewhat. Here in this problem, once I put I equal to 0, okay, so this we got as cos 0 equal to 1, and if I put I equal to 180 degree, so we get this as minus 1. So, there is no ambiguity, this is the point where I was telling. So, for that case we can put here, in this place that I lies between 0 and 180 degree. It will not produce any ambiguity, as we can see from this curve. This is the cos curve, which is going from 0 to pi. Okay. In this portion this is positive, in this portion this is negative, and therefore, no ambiguity here. But for the sin is always positive between 0 and 180 degree. So, this is always positive. This quantity capital omega, it varies between 0 and 360 degree. So, we have to fix it up. So, how do we fix up? We know this quantity is positive, here this quantity is positive. So, if we know from this place sin capital omega and cos capital omega sin, which will be nothing but h 1 divided by h sin I and minus h 2 divided by h sin I. So, depending on the sign of both of them, we will be able to resolve in which quadrant they are going to lie. Okay. It is a very simple resolving it. So, this is the objective. So, you can see that by the scalar method or by the vector method, here this is also a vector method, but the work is little different. We have the way you see that how we have proceeded. Okay. We have taken an unit vector along this direction, and then we have worked out. So, this is bit longer, okay, but no doubt it is a longer, but it is another way of solving the same problem. So, as I told you, in the mechanics we solve the same problem in multiple ways. These possibilities are there. And moreover, also I would like to remind you that whenever you detect any error during your course, because while writing this error is bound to creep in. Okay. So, if you find any error, so you can report it during the while the course is running. So, later on also we can edit it. Okay, so we have done this part. Now, what we are going to do? We know this vector, okay, and let us assume that this E cap vector which we were earlier knowing, this is not known. Suppose this is not known. This is not known. So, in that case what we will do? If this vector E cap is not known, so there are other ways of doing this. So, in that case what we do? We take this, okay, and we take this part, and also this is the vector. So, utilizing this, then we will be able to solve the problem. So, let us see how do we do this. So, I will finish in this lecture this part. So, E n cap we have written as cos capital omega E 1 cap plus sin capital omega E 2 cap you can see here this is theta plus omega. So, the angle between from this place going from this place to this place, okay, all the way, this is omega and this is theta. So, omega plus theta, this is the angle between this vector and this vector. So, here we have written this. So, this gets reduced to r cos theta plus omega, and this is r the r dot E n cap, and we know the E n vector and r vector also, and therefore, we will be able to solve it. So, we can write here as r 0 cos theta plus omega, this equal to x 0 E 1 cap plus y 0 E 2 cap z 0 E 3 cap times E n cap is cos capital omega E 1 cap plus sin capital omega E 2 cap. So, therefore, this gets reduced to x 0 cos capital omega plus y 0 sin capital omega. So, this is r 0 cos theta plus small omega. So, this is one equation. Let us name this as equation A. Now, unit vector along the OM direction, along this direction, this we can get, okay. And if we know the unit vector along this direction, so from here to here this angle can be computed. Theta angle is it is wrongly shown here. Theta angle is from this place to this place. This is theta angle. Theta angle is not up to this point. So, theta angle is from the argument of perigee to this point. Okay. This is your theta angle. So, here this part, perhaps I have shown only this part here. So, this is theta. This is and this angle is omega plus theta, which is omega angle is from this place to this place. This is omega. Okay. So, omega plus theta minus 90 degree. So, repeating on the same figure, the figure gets complicated. So, omega plus theta minus 90 degree. So, this angle if we know and the vector along the OM direction if we are aware of, we will be able to work out another way. So, here again we write r 0 dot E cap OM. Okay. So, this will be r 0 magnitude EOM cap magnitude and angle between them is cos here theta plus omega or omega plus theta minus 90 degree. So, this becomes r 0 cos 90 minus omega plus theta. So, this is r 0 sin omega plus theta, and on the left hand side this is r 0 dot EOM cap. So, we need to know this EOM cap. If we know this, then we will be able to work out this problem. So, we need to know EOM cap vector, this we have to determine. So, again going back, coming to this figure. So, you can see that along this direction this component will come from E 3 cap. E 3 cap, the angle again I will go and draw on the next page this figure, without that it is becoming very complicated. Okay, I will draw the figure here. This is the M direction, this is O, somewhere here satellite is in this place. So, this is S. Okay. So, we are looking for EOM cap. E 3 cap is along this direction, this is x, y and z. So, you can see that EOM cap vector, this can be composed of, this angle is 90 minus I, 90 minus I. Okay. So, E 3 cap cos 90 minus I and plus, then we have the footprint of this orbit on the xy plane. So, this footprint is from this place to this place, and this we have here written as this point as M, and in this direction we have written as this is M, this is M prime and this is M double prime. Okay. So, we need the OM prime vector, okay, and this angle we know that this angle is I. So, we have to write here EOM prime cos I, okay, and then we have to write this value how much this is. So, this we have already worked out, and this vector is basically minus cos I sin capital omega E 1 cap plus cos I cos capital omega E 2 cap plus sin I times E 3 cap. From where we are getting this? See, E O double M prime we already have here. Okay. And EOM prime is also there, EOM prime is here, okay. EOM prime, this is available to us in this place. So, we use this E O m prime is minus sin I E 1 cap cos I times E 2 cap. I will write there sin and cos, sin and cos. Sin and cos, sin cos capital omega E 2 cap. So, E O m cap what we have written here, this vector component and this vector component we are taking, multiplying it. So, this is E O, I will erase it, this line let us erase and work out properly. There is a error in here. See, this part is okay. Here along this direction we have the vector E O m prime cap. So, component of this vector along this direction is E O m cap, this component and this component. So, E O m cap will be defined, which we are defining here. So, E O m prime cos I. So, we write here E 3 cap sin I plus E O m prime, which is here, which we are writing from the previous page, E O m prime minus sin capital omega cos capital omega minus sin capital omega cos capital omega. So, minus sin capital omega E 1 cap plus cos capital omega E 2 cap and this is not a dot product here, this is simple thing, and then cos I. So, once we expand it, so this is E 3 cap sin I and then expand it again minus sin capital omega cos I times E 1 cap plus cos capital omega cos I times E 2 cap. So, this is E O m cap. So, now once we know this vector, so this is what I wrote earlier. So, I will rearrange it, write first this one. So, minus sin capital omega times cos I E 1 cap plus cos capital omega cos I times E 2 cap and plus sin I times E 3 cap. So, this is in proper order. So, this is E O m, this is E O m cap. So, once we have got this, now it becomes easy to work our problem. So, what we were doing that we have written this equation. So, you see that on the left hand side R 0 is already known. So, this is also known now. So, on the next page we can write R 0 is x 0 E 1 cap plus y 0 E 2 cap plus z 0 E 3 cap and dot product with minus sin I sin capital omega cos I minus sin capital omega cos I times E 1 cap plus cos capital omega cos I cos capital omega cos I times E 2 cap and sin I times E 3 cap, sin I times E 3 cap, and this is nothing but this quantity R 0 sin omega plus theta. So, this is R 0 sin omega plus theta equal to this quantity. So, right hand side we rewrite it, it is a dot product. So, it is easy to work out, minus x 0 sin capital omega cos I plus y 0 cos capital omega cos I plus z 0 sin I. Okay. Okay, so, these terms are correct. Once we have done this, so r 0 sin omega plus theta is available and r 0 cos omega plus theta is also available. Now, if we divide r 0 sin omega plus theta divided by r 0 cos omega plus theta, then this gets reduced to minus x 0 sin capital omega cos I plus y 0 cos capital omega cos I plus z 0 sin I divided by r 0 cos omega plus theta, that we have to bring in r 0 cos, this is x 0 cos capital omega, y 0 sin capital omega, x 0 cos capital omega plus y 0 sin capital omega. So, this implies tan omega plus theta, this will be the quantity in the bracket here. So, this way we have been able to determine omega plus theta. Now, you know that theta already we have determined. So, theta already we have determined. So, omega plus theta minus theta, that gives you omega. Okay. So, this way once we have obtained this, what we have done, a, e, small I, capital omega and theta already we have determined. So, in this method we are determining together omega plus theta, and from there we are then subtracting this theta to get the value of omega. So, omega can be determined in this way. Now, there is a problem with this. While we try to do this theta plus omega estimation, okay, and theta estimation, and from there then you are subtracting this, and this is from here you are trying to get this omega. So, what happens that you know that x 0, y 0 and z 0, these are not known exactly. Okay. These are never known exactly. This is, you can take it for granted, because these are obtained from rho dot information after processing from multiple ground station. Okay. So, they will have certain amount of error. So, if you try to use this, so the error creeps in this value, and also error has crept in this value. So, the error is also coming here in this place. So, somehow sometimes they get combined and the error in this omega, this gets magnified, okay, and therefore, this method using this method, it is not very good, that we determine theta plus omega, and from there then we determine omega. Whatever we have done earlier, we have separately determined omega by taking the angle between this E n cap and along the perigee direction I have not drawn here in this place, but we can draw this here also. So, I will do it in the pink. So, somewhere let us say that this is the perigee direction. So, this is P. So, this angle from here to here, then this will be your small omega. So, between this vector and this vector, if we are trying to find the angle omega directly, so this is much superior. Okay. And thereafter, between P and S, whatever the angle is there from this point and this point, then we can get the angle theta. Otherwise, using this method, the scalar method that I have followed, there it is prone to this error problem, because x 0, y 0, z 0, x dot, y dot and z dot, they are never known exactly, and therefore, we have to be careful while doing the orbit determination problem. So, once you get into this area and we work on all these problems, so you will come to know what are the problems you are facing. So, I hope that for today this is enough. I will stop here. The inverse problem is remaining. So, I thought of finishing it by 15th lecture, but I will have to go to the another lecture for the inverse problem, that is getting A, E, I, capital omega, small omega and theta, all these are given. From there you get x, y, z, x dot, y dot, z dot. So, this we will do in the next lecture. Thank you for listening. Thank you very much.